Welcome to the next unit of week 12, module on collaborative and game-based learning. In the previous module, in the previous unit, we saw how to work with collaborative learning model. So now we will try to understand game-based learning in this particular unit. So gamification and game-based learning is becoming a useful approach under certain scenarios. So basically what is gamification? So we want to bring in the elements of games in the context of learning for to motivate the specific learning behaviors. And so basically what we feel is that there are situations where when you assign certain activities based on uniform level of achievements for everybody, and so now you say that you have a 15 mark some particular activity for say 15 points, 15 marks is what you give. So the motivation levels for all of them, maybe at a certain level, people are happy to get 15 marks, and then they'll just do, and then they don't even know how many marks they will get, and then they will wait for the instructor to complete the grading and tell them this is how well you did. So the game-based approach takes a slightly different strategy for ensuring that students always try to give their best, right? Just like in a game, which means that there is a small element of competition that is invoked, right? So there is we can talk about giving points based on certain intermediate deliverables, certain badges for accomplishing and completing certain milestones, leaderboards, right? So what is the difference between an individual assignment or a homework versus the doing it in a game-based context? The thing is that there an individual's progress is made visible to everybody else. Okay, so that's exactly the point, which means that for example, you talk about points and badges. So what will happen is, in a game-based environment, anybody will be able to click on a student's profile and then see how many points, badges that they have, badges of honor as we call it, how many stars have they earned for their activities. And so this may inspire and motivate them to also start gaining points, and so eventually these points can translate into grades in some way. But the critical component here is to make it visible. That's where the competitive nature comes into the picture, right? And so these are more of external motivators, right? As they keep saying, that's where the leaderboards are also very important. So what happens is, so these are all things that are once again not done at the end of completion of this whole activity, right? So which means that there has to be enough intermediate mechanisms to share these achievements and celebrate their achievements in a much more continuous manner than the traditional activity-based learning. Okay, so this obviously requires a good amount of planning and tools and so on. So which means that you have to actually create a game, right? So which means, what are the elements of a typical game? So there will be, in any game, there is the concept of everybody getting their own turn to do an activity, and there is also a way to say whether they completed that activity successfully or unsuccessfully, or if they have done it successfully, what is the level at which they have done, whether they have been fully successful, partially successful, right? So those elements will, that is one important part of it, which means that the completion of that activity should involve multiple people taking, doing their work in discrete activities. Okay, so which means that there is an overall activity that is planned. There should be sub activities called A, B, C, D and E, right? So which means that, depending upon the domain we are talking about, which means breaking it down into smaller sub-activities is an important prerequisite for this. Once you have done that, so people now can compete with each other, and obviously we cannot take this too literally, because there could be certain games wherein you are allowed to pull somebody back and you move forward. But obviously we have to design the game in such a way that you, an individual learner, is not able to, you can go ahead of somebody else only by doing better, but not necessarily by disrupting somebody else, right? So that is something that one has to keep in mind when designing this game-based learning. And so this is where there's a lot of motivational aspects are shown to enhance the overall learning experience. So these are, whenever you talk about computer games and so on, so there are very clear objectives. So they will have, there may be multiple levels that are created, as I mentioned. So you break down the overall activity into level 1 activity, level 2 activity, and so on, with possibly increasing challenging levels, increasing difficulty levels, and so on. So which keeps the students hooked on to that particular learning activity, and they should be striving for mastery. Immediate and frequent feedback is mandatory for the success of game-based learning, right? As I said, if you just wait for the end of the semester to give feedback on those individual rounds, individual levels of achievement and so on, then it is not really game-based learning. It is much more traditional learning that you are trying to do, which means we have to be able to provide immediate feedback and even break it down into opportunities for them to attempt it multiple times. It has to be made context sensitive. We have to create real world scenarios that will provide meaning and ensure that the abstract concepts are relatable from in this particular case, right? Again, as a computer science professor, I can tell you that you say algorithms, right? So algorithms is all about choosing the strategy for solving a problem in a very efficient manner. That efficiency can be measured in terms of the time it takes for a particular program to run, or the amount of memory it occupies. Now, when you look at many of the hackathons, online hackathons like HackerRank, so they have all gamified to the extent that they will once a student submits their program, so they will evaluate it. They will announce saying that okay, it took this many seconds, this many milliseconds to complete. It occupied this much of memory, right? And then people are ranked based on the efficiency with which they have implemented their solutions. So this has to be made quite context sensitive and gripping as well. Okay, so this is where we have to create lots of variations of the problem. Now, because we merely saying that you have to write a program to sort numbers, right? So that is probably not very interesting. So you have to make it much more interesting, create much more creative, be creative with respect to creating different kinds of scenarios wherein the sorting of this, the sorting that is involved, you can bring in additional dimensions of how quickly you may want to sort, and what is the bulk of the data that you're trying to incorporate. It could be even the type of sorting that you are doing. For example, are you trying to sort images based on some specific aspects of it, right? So if I have 5 images and you say that each image has got different number of balls in it, so you have to efficiently sort it. So which means that the sorting of the images itself is one part of it, but even recognition of those images those balls in each of those images also becomes a very specific challenge that you put in. right? But why is this? What is the other big benefit of this game-based approach? Is that it is all about safe failure. It gives the opportunity for people to take risks and fail without any real world consequences, because much of those game based environments are all simulation oriented, and in simulation oriented environments it is perfectly okay to fail in a very safe manner. Okay, so from an engineering perspective, there are plenty of benefits that we can look at. Definitely problem solving skills is enhanced tremendously, right? So we can create games wherein you throw in lots of parts together, and what is the most efficient way of joining these parts, these components to the components, again, can be hardware components, software components. How do you assemble them together to solve the problem more effectively, right? So this really enhances the critical thinking and decision making process also, right? So how do you evaluate multiple strategies, right? So against various parameters. Overall systems thinking is also is encouraged as part of this, because you are not trying to write one particular program or build one particular component. Now these components have to interact with each other, right? So that also promotes systems thinking. Okay, and many of these game-based approaches are inspired from computer games, and computer games are inherently visual in nature. So this also encourages them to think about visualization and spatial reasoning as well, and procedural knowledge, right? So it's just not you need to be able to know what is the procedure to even assemble them together, right? So there are these individual components that do certain things, but how do you put them together? As I said, if I take the same example of sorting images based on the number of balls that are there, right? I may be giving them the algorithms for individually recognizing the balls that are there in each picture, and there may be an individual sorting algorithm, right? So how do you take the output of one function and pass it as an input to the next function? That is more of a procedural knowledge. So they need to know the programming techniques that are involved there. So the same is true with any kind of gamification that we are trying to do, right? So there are lots of very interesting games have been created based on Lego blocks, right? So when you're talking about Lego blocks are these tiny little pieces with which you can create very sophisticated mechanical components, including engines, gear systems, and so on. So they need to understand the principles of how gears work. How do you assemble gears together from these individual components, right? So depending upon the discipline, we can work on many disciplines of engineering. Almost every discipline of engineering can benefit from game-based learning. Now we can think of simulations. If we are talking about large-scale, industrial setups, obviously you cannot be playing games in a real-world industrial setup. Simulations are extremely good. Puzzles, creating puzzles which will try to figure out, which will encourage them to put together solutions and create specific shapes from individual components, right? So these are all very, very nice. Role-playing games are also becoming, as a great tool, especially for larger context, right? So we can create multidisciplinary games as well, wherein people belonging to the mechanical engineering department are playing a specific role, and whereas the civil engineering department is also there. So there are game of life is the equivalent of that, right? So how do you do city planning? How do you work with? We constantly keep complaining about the civil engineering department digging up the roads while we have the road planning and infrastructure development, people saying that no, these people are the reason why we have so many traffic jams and things like that, right? So this can be very interestingly put together for collaborative as well. And in terms of the tools, definitely if you want to incorporate game-based learning, you have to look at tools, right? And virtual reality and augmented reality equipment is probably a prerequisite, I would say, for creating very effective games, right? Wherein if you are not able to do things in a real setup, because especially in non-computer science or non-computing kind of environments, safety is also a major concern, right? So you have to ensure that if you to create a safe learning environment, because we also said that it has to risk-free failures should be there. So safety also becomes an important part of it. So which is where virtual reality and augmented reality, AR, VR, as we say, they play a very useful role in creating game-based learning. I'm sure you would have heard of digital twins as well. So digital twins are also provide us very safe learning environment, wherein there may be a very sophisticated equipment that is there, but for example, you talk about an industrial robot, right? So the industrial robots can be quite heavy, quite quite dangerous, right? So if you are trying to program an industrial robot to do a specific task, like picking up a thing and then moving around and then placing it somewhere else, so if there are defects in that particular programming of that, then it could be dangerous, right? So actually it could hurt because it will be heavy. So to prevent such injuries, so we can, there are digital twins that are available, which will give the same level of feedback and appearance and look and feel of operating the real equipment as well. Okay, so we can, this is definitely an option to provide a risk-free failures and a safe gaming environment. Of course, interactive animation software is something that can be used to custom create games for the purpose of learning. Okay, so when we talk about how do you evaluate learning games in terms of the effectiveness, whether it is useful or not? So one is obviously the fitness for the purpose of the learning objective itself. You should look into it, right? Because unlike computer games, here the fun is not the only goal that we want to achieve. So there has to be some kind of a learning objective that we want to achieve, and it also makes sense to create some amount of real world relevance, right? Which means that there has to be some reflection of the real world engineering challenges. So which also might lead you to choose an appropriate tool. As I said, if the real world challenge I am going to solve involves industrial equipments, then the choice of simulation tools comes into the picture. Or if there is a safety is also a concern, then the use of digital twins comes into the picture, and so on. Okay, and of course there has to be fun element. All I was trying to say is that fun element should not be the only thing that is there. So it has to be fun, it has to be challenging, and it has to be intrinsically motivating, because the whole idea behind is introducing game-based learning is actually to motivate the learners from the learning perspective. So in fact, the gaming environment should be such that there is continuous feedback that is provided, because as I said, so that they can know how they are faring within that particular activity, and how are they faring with respect to the others as well. And of course, keep in mind that you have to ensure accessibility is taken into account. These days, we want to create safe learning environments for people, for persons with disabilities as well, right? So, so that they don't get excluded, which means that which is where all the simulations also are very useful, and especially if you are talking about simulations, then you also have to look at what kind of persons with disability can be accommodated. Are we thinking about visually impaired students, or are we looking at people with limb disabilities and so on? So this all matters depending upon the discipline where you are trying to incorporate learning. So game-based learning is really a powerful pedagogical tool relevant for engineering education, because there is a lot of opportunities irrespective of which discipline that you are working with. Okay. So it also provides a lots of internal and external validation of capabilities, right? So what do I mean by internal validation? Their own ability to complete a certain task and immediately come to know whether they are succeeding, not succeeding. That is one part of it. The external validation is more in terms of the number of badges that I am getting with respect to somebody else. How am I doing relatively? All those leaderboards, they are all part of the external validation of their own capabilities as well. So there are lots of tools that are coming up to create course specific custom games. I think you should, for example, depending upon which department you are teaching in and which discipline that you are teaching in, do look for lots of tools and kits that are now available. As I said, just the Lego itself, they have lots of learning kits that they have put out, which can be procured in the in a laboratory environment. So or they can be lots of online digital tools as well. Okay, so that is how game-based learning can be very effective under certain specific conditions for learning.